Hi, my name is Dennis Angel and I'm a core developer for XRPL Labs. Today we're going to be discussing a deep dive into protocols, data structures, and communication. So to start off, we're going to go over the agenda. What is a protocol? We're going to talk about data structures, serialization, message handling, version negotiation, network communication, and then we're going to wrap up with a summary. So to start, what is a protocol? A protocol is a set of rules and conventions that enable different systems and components to communicate and exchange information reliably and predictably. Protocols are essential in ensuring data is sent from one node to the other and interpreted the same exact way, even if they are built by different organizations or different technologies. So the next topic is data structures. So what are data structures? Data structures are organized formats for storing and managing data. In the context of protocols, data structures define how information is grouped, labeled, and related. They provide a blueprint for what kind of data can be sent or received and how it should be interpreted. So why are they important? The first one is clarity. They ensure both the sender and the receiver have a shared understanding of the data's meaning. Consistency, they prevent ambiguity so that the same data always means the same thing. Extensibility, well-designed data structures can extend to support new features without breaking existing functionality. So some key concepts here, the main thing is fields. Individual pieces of data such as numbers and strings, they're all type defined. There is no number, it's a uint32 or a uint64. Strings are a variable length. Optional fields have to be specified, so some data may be present only in certain situations, allowing for flexibility. And then you have nested data structures. So data structures can contain other structures nested inside of it, and it's important that those aren't ambiguous, but well-defined types. Next is, what is serialization? Serialization is the process of converting data structures into a standardized format that can be transmitted over the network and stored. This format is unambiguous and consistent so that the receiver can reconstruct the original data from the serialized form. Why is serialization necessary? It's important for interoperability so that different systems may use different internal representations, serializations, and provide a common ground. It's also more efficient to serialize data and send that over the network. And then integrity. Serialization ensures that data is not misrepresented due to differences in system architecture. Some of the key concepts. The serialization provides a canonical format, so a single agreed upon way to represent data, avoiding confusion. Encoding, which is the method to represent the data, binary or text-based. In the case of RippleD, we use binary encoding, and that is why it's referred to as the binary codec. And then last being the deserialization, which is reversing the process and reconstructing the original data from the serialized form. So the next section is message handling. So what are messages? Messages are units of communication exchanged between systems or components. Each method typically contains a data structure serialized for a transmission and may include additional metadata such as sender, recipient, or a message type. So why is handling messages important? For coordination, messages allow systems to coordinate actions, share state, or request services. It's also important for reliability. Proper handling ensures that messages are delivered, processed, and responded to appropriately. And then finally, security. Message handling can include checks to prevent unauthorized or malformed messages. Some of the key concepts with messages are the message types. So different kinds of messages serve different purposes, requests, responses, or notifications. Optionality, as we spoke to before, some message fields may be optional depending on the context. And error handling. Systems must handle unexpected or invalid messages gracefully. The next session is version negotiation. Version negotiation is the process by which communicating parties or nodes agree on which version of the protocol to use. This is very important because as protocols evolve, new features can be added and old ones change. So it's important for a consensus to ensure that both sides understand each other. So this is some of the things that make this necessary are backward compatibility. So this allows newer systems to communicate with older systems. We also have forward gradual adoption of new features, and then the flexibility, which allows support of diverse ecosystems where not all the participants upgrade at the same time. Some key concepts. Some of the key concepts of version negotiation. We have explicit markers indicating which version of the protocol the node should be using. There's a negotiation process, a way for parties to propose and agree on version changes or new amendments. And then we have graceful degradation, which if a feature is not supported, systems can fall back to a compatible mode. So finally, we have network communication. What is network communication? This is referring to the exchange of data between systems over a network, such as an internet or a local network connection. Protocols define how connections are established, maintained, and terminated, as well as how data is routed or delivered. Why is this important? Because it enables distributed systems to work together regardless of physical location. It supports scalability, so large number of participants and high volumes of data, and resilience, so protocols can include mechanisms for detecting and recovering network failures. In summary, protocols are the foundation of reliable, interoperable communication between systems. By defining clear data structures, using serialization, negotiating versions for compatibility, and managing network communication, protocols enable complex distributed systems to function smoothly and efficiently. Thank you.